Hey everybody, welcome to another session of HashiCorp user group and the CNCF community group. Today we'll be talking about guardrails in Terraform. Joined with me today is Ben. Ben, would you like to give just a brief description?
Yeah, so as Brad mentioned, we're giving a bit of a talk on Terraform Guardrails. And what we had done is use these two tools, Open Policy Agent and TFSEC, the two things that you see on screen right now. And we'll be giving a bit of an introduction on what these two tools are, how they work, and how we've leveraged them into something that we have been using thus far, and we really like it.
Yeah, so maybe a bit of the why as well. So in the past, I've worked with lots of companies that adopt Terraform, and they never really get to a mature state of actually setting up guardrails in case people do things wrong. So generally, the cloud team would do it and they'd have their pipeline set up. And there was nothing really to stop people from, if you accidentally delete, a critical resource that is going to break production. And also, just because you do infrastructure as code doesn't mean that you're doing, you're not making security vulnerabilities in your code. So when we started, when I started working for one company, it was a lot different to traditional. So it was with domain-driven design. And what I found is that because they wanted the engineers to be able to do all the infrastructure as code, we soon realized that, okay, we've got to set up guardrails. Otherwise, we're going to see things, and we did see these things as security vulnerabilities coming in production. The cost bill went up crazy because developers don't generally do lots of infrastructure, so they don't really care about it because they're not accountable. So therefore, we needed to make a solution. So yeah, like Ben said, what we came up with is we came up with a way where in our pipelines we can leverage some open source software. So all of this is done open source, and we essentially just built a wrapper around Open Policy Agent and TFSEC. So we wrote some code in Golang, and what we did is we'll talk about this soon, but we have a policy saying if you delete any of these resources, then you need to do a manual deployment. So as you know, in Terraform, you can go auto approve, and then it's just going to push all of your changes, into production. Whereas we want that because we want that DevOps capability, but we don't want to, push disaster changes in there. So if you don't meet the security standards that we have low, high, and critical. And if you don't meet the policy, then therefore a developer has to manually sign in to the CI/CD tool and then click approve or to go further.
Mm-hmm. Yeah, to go on from what Brad had said, the whole Terraform auto approve thing. I mean, best practice wise, you shouldn't have any developers deploying code directly to prod. You want it all to be done through a pipeline. But the way Terraform works is, when you type Terraform apply, it outputs a whole bunch of stuff and says, do you want to approve? And doing that through the pipeline, it doesn't let you interactively type in the yes. You're kind of forced to use the auto approve path, which could be dangerous. And that's what this thing that we've done is trying to solve. So I guess before we go too deep into what we had done, maybe we'll talk a bit about Open Policy Agent and TFSEC, what exactly or how they work. Open Policy Agent, as you see here, it doesn't only cover Terraform, but we'll be speaking more specifically on the Terraform aspect of it for today. Let me see if there's the documentation for Terraform. Here you can see some of the example cases. Terraform.
So you can use it in Kubernetes with Gatekeeper. You can even use it with, essentially you can write a policy for anything, but a lot of people use it as Gatekeeper in Kubernetes. Docker, Terraform was really cool. Yeah, you can see here that maybe you want to talk a little bit about that, Ben.
Yep. So how Open Policy Agent itself works, it takes in this rego as an argument, as well as the template. What you have to do is you specify what is an acceptable score and how things are being scored. Like in this particular example you see here, it's saying that consider 4 resource types: an AWS auto-scaling group, AWS instance, IAM, and launch configurations. Now, out of those 4, it actually gives scores towards 2 of them, which is, say, in this case, an auto-scaling group and an instance. If your Terraform plan has involves deleting an auto-scaling group, that is worth 100 points. And this is where you actually set your criteria. If your score is higher than, in this case, 30 points, that will just fail it. As you can see here, score less than blast radius. They named it a bit interestingly. I wouldn't have called it blast radius. I would have just called it maximum acceptable score or something along those lines. And that's actually exactly what we did in our version of the retro. But this being an example, let me just bring up an example of one of our retros so we can compare and contrast. So what we had done, it's the similar type of dot retro that you see in Open Policy Agent. I might just zoom in a little so everyone can see it clearly. Now we've actually defined things in 3 different categories. It's either critical, important, or low risk. And how we determine that is critical resource, any changes at all will require a human cross-check. Like in this case, a SQL server, a SQL database, we deem those as quite critical, important resources. So even if you're just modifying it, we want to know about it and flag it before it automatically gets deployed. Whereas for important stuff, yeah, you can modify it by, say, an app service plan or a key vault. Occasionally you're upscaling or downscaling plans. That's fine. We assume that's part of your routine. So we put a score of 1 on the modification, and therefore it should generally pass a test, but you're not allowed to delete it. As you can see, instead of blast radius, I literally called it max acceptable score because that seemed more intuitive. So as you see here, with a max score of 2, you can modify 2 resources and it will still automatically pass the test that it's a safe deployment. And for the low risk ones, that's what we've done here. You can delete potentially 2 items, but once you start deleting the 3rd item, we believe that may not be intended behavior, so it will require a human cross-check. So that's exactly how we've done and categorized them into these 3 sections, and using a bit of variable so you don't have to repeat that again and again everywhere. But using this, it's very much a plug and play, find replace business. You can set your score to, instead of 2, I don't know, maybe you could have it as 5. You could modify 5 things before it needs a human check. So this essentially is what the Open Policy Rego policy, I guess we could call it, how it is done the way we want it to. And that's exactly what would happen. And when you evaluate it, what happens is it just tells you, does it pass tests, true or false, a simple Boolean, which makes it very handy to use in pipelines. Or in the second option, another thing that you could do is actually find out the score. If it says false, you failed the round. What was the score? Was it, if the score is 11, then yeah, clearly that exceeded the acceptable score, and that's why you failed. So that's how Open Policy Agent works and how we've leveraged it and built it on. Brad, do you want to talk about TFSEC, or should I?
Yeah, we'll talk a little bit more about Open Policy. So
Yep.
We have it for all the cloud providers, well, the 3 main cloud providers as well. So we have policy for GCP, AWS, and Azure. So the beauty is here that you can leverage whatever cloud. You could even do multi-cloud if you want to have a policy for that. But we're leveraging Azure at the moment, but we have the policies for the other ones also. So it can be, like Ben said, plug and play, which is pretty cool. So we've found OPA to be really good with auditing and compliance as well. So it's quite a cool tool to pick up. Yeah. If we and then we'll talk about TFSEC. So we can have a conversation about that. So for those that don't know TFSEC, it's essentially static code analysis for Terraform. So you can, run it on your computer in pipelines, pretty much wherever. It's very well done. Very impressed with it. So I've started using TFSEC for quite a while, and then we found that it was really good for doing the reports and that, but we wanted to. That's why we made this Terraform plan validator. So it's leveraging the open source. So it's not reinventing the wheel. We're just putting a little bit of business logic in it as well, just for our pipeline, so we can say, okay, these are the outputs of TFSEC. These are the ones of OPA, and then to fail or not. So you can see in this little GIF here that they have the Terraform code, and then you run essentially TFSEC command, and then that will say, okay, I've found these 10 critical resources. And if you haven't run a static code analysis on Terraform, I recommend you do it, because you'll be very surprised about how many things you're doing wrong. Especially when it comes to IP whitelisting and those critical ones like secrets management tools, like Key Vault, AWS Secrets Manager. That there's a lot of things that you can improve on there as well. So that's essentially TFSEC. Do you have a report there, Ben, that we could show?
It's quite good to note that these errors that they flag it's not necessarily purely straight from TFSEC, because they do reference back against your Azure or your GCP and AWS documentation. It says this is the documentation from AWS that says this is a bad thing to do, and so it's actually fully, as you can see in a sec when that shows up. See, there's like TFSEC, that's the error message, and where on Terraform the module is, as well as the documentation on the cloud provider itself, saying this is a bad decision because of X, and how exactly should you resolve it. It actually tells you when you get to the actual docs itself. I wonder, that's not supposed to happen. But yeah, when you get to one of those docs itself, which will show subsequently, it tells you, okay, your website is currently using, say, HTTP. You should use HTTPS instead. So it actually isn't just telling you the problem. It offers you some solutions, or guides you in the direction that you should go towards to make your code safer, better generally. And in a nutshell, that is TFSEC. Do you want to bring up one of the example reports to see what it's like?
Yeah, we can do that. Yeah. Maybe we can show the pipeline, like a pipeline in either GitHub or probably the Azure DevOps one as well, if you have it. Just to show the people how we're gluing all this together. It'll be quite nice to look at, I think.
Okay, so firstly, this is the pipeline YAML, and let's just put this up on the screen. That's AKS. So if you go through GitHub Workflow CI YAML, you'll see this is the YAML that's doing the entire pipeline. And if you just go to actions, you'll be able to see the result of what exactly it's doing step by step. So let's just go, since we were talking about TFSEC before, this is exactly what happens with a TFSEC report. It tells you, all right, like in this case, the Kubernetes cluster is defined without an IP address ranges to the API server. It shows you what your code was that you've written, and it tells you what the impact any IP can access, what you should do to solve it, and you get the 3 docs, one of it being TFSEC's own doc saying, this is suggested resolution, this is the bad example, good example, give a specific IP range, and you go to Terraform's docs itself and tells you what the exact thing is that you're supposed to pass in. And finally, the actual content from Azure saying you should do this because reasons. Right? Some of it's quite self-explanatory. Like in this case, you want to make it secure and not open it to the world, so to speak. So that's an example of what TFSEC can do. And it also sort of categorizes them under critical, medium, and there's a summary down at the very bottom. What we had done in this case is we enabled verbose logging to give you the full context of everything. TFSEC does come with other commands like TFSEC. I think it's concise output -- concise output that makes this less text, and I think it only outputs just the results. But in our case, we actually want to see everything as it happens, so that's why we opted to go for the full suite. And here you go. At the very bottom, you see 4 potential problems in critical and medium vulnerabilities. So I guess at this point, we should talk a bit about how we've integrated this into our pipeline. As you can see here, this goes through, sets up the job, and initializes a container. Maybe we'll talk a bit about the container itself. So this is what we have done. It's a Terraform plan validator image that gives you, at the moment, I'm not sure about the send report. Brad, are we good with the send report one, or we'll just talk about these three for now? Yep.
Yeah. I guess we'll quickly go over the capabilities. So
yeah.
The send report is gives us a pretty slack dialogue, which looks quite cool. So anyone that tries to push or do a PR that has vulnerabilities that are, let's say we put high as our threshold. So if it's high or critical, then that will be sent to Slack, so it gets flagged as a security concern. TFSEC will output the vulnerability report. OPA score report will give you the score, of the percentage, or probably not the percentage, but the score that it gets given against the policy.
Mm-hmm.
And then obviously check as well. So the check will see if it passes both TFSEC and OPA policies.
Yeah, so those two are the equivalent of this step here. Check gives you a Boolean and score gives you the numeric number. So that's what those two do. Those are the TFSEC side of our image, and the OPA side, and this is the TFSEC side. And that's just a curl webhook type thing that sends it to Slack. So how you use this, you could run them as a container. That's the link to the Terraform plan validator. Well, you can see that up here as well. And you do have a few options. Like by default, we have passed in the Azure policy that we have used, the one that I had shown you earlier, which is this thing with our default specs. So obviously you can bring your own policy. You just swap in whichever it is you want. Like say, if you wanted to put a virtual machine, for example, in the critical resources thing, you can just take this entire regio file, edit it as you see fit, and pass it through into the container itself, and then it will just be used in lieu of our default Azure policy regio.
And pull requests are welcome as well if people want things added into that.
Yep. So this is the pipeline itself. Quite a few steps. So what it does is it runs on Ubuntu under that container that we had just talked about. Let me just zoom in a little since it's okay. Runs on that container. Now this is Azure specific, so we have to pass in ARM client ID, client secret, subscription ID, and tenant ID. Now, if you were using AWS or GCP, you would have to insert the equivalent environmental variables for the purpose of Terraform in this case. Terraform uses these 4 environmental variables to authenticate itself to be able to deploy resources. Now, once those environmental variables are in place, simple steps. You check out, basically pull your code. Init, what we have here, cd path to Terraform files, that's purely because in our AKS, let me see.
It'll be under source, yeah.
Yeah, this is like the root directory of that repo. Our Terraform files are all inside source folder, all the .tfs you see here. So that's why, that's why we're cding into path to Terraform files, which it just goes to source in this case. And I just made that a variable because we will be doing this cd multiple times. You could change working directory, but at the moment, this is what worked, and we didn't want to change what's not broken. So you go inside, it's your standard Terraform steps. You init. Right after you've done the Terraform init, you run the TFSEC. And in this case, we've also added this soft fail option because we didn't want it to basically fail the pipeline. We just want to output this report that I had shown you earlier. Outputs it so that when we check the pipeline down the track, we will know that there are vulnerabilities. You could always just omit this soft fail portion if you want the pipeline to actually stop running. You want to make sure that all the errors are accounted for. That's optional. You can always just take out that portion. Then once it's done the TFSEC report, which let me just open these two side by side. That sorry, I'm sharing just one window. That didn't work. Anyway, so the steps here, Bill, I might need to. So that's TFSEC report. The next one's Terraform plan. Terraform plan is, well, pretty straightforward. Your regular Terraform plan. In our case, we are using the TF vars. So we're just out using the var file here, and we're outputting a Terraform plan. Now this output a TF plan part is quite important because when you use the OPA, this open policy agent tool, it can only accept Terraform plans in JSON format and not your regular binary Terraform format. And that's why we need to output a Terraform plan. And in the next step where we're validating it, Terraform has a command where Terraform show -JSON. You take the TF plan as an input, output it as a JSON. And after that, you are now able to use the Terraform plan validator to work through it. Now, this is the part that when I said earlier that you can use the rego that you want, this is what we're doing. We're just taking in the default environmental variables and the default Azure policy rego to paste it into the folder. In your case, if you want to do something else, you can just copy this from your source folder, like the cp that /source.rego, or just straight up put your OPA Azure policy rego right alongside here. You just put it out at the root level, and it'll be able to pick that up. Sorry, I said root level. It's supposed to be in the right adjacent to your Terraform plan. So you'll have your rego right alongside your Terraform files, which logically kind of makes sense as well. You just put that there. And now this is the part where we're just generating the report. So running the Terraform plan validator, check, and this was the part that we spoke about earlier, where it just gives you a Boolean. It checks it, it passes in the plan, which is GitHub SHA. Sorry, that's just the JSON, the plan. And -C, that's for cloud provider, Azure. So you could use Azure, GCP, or AWS, and all that does is it picks up the specific OPA-Azure or -AWS or GCP policy.rego file. Otherwise, yeah, if you wrote that as AWS, yeah, it'll just search for an AWS policy. So that gives you a Boolean value for validation pass. And score itself, that's just the number. So it's the same process. Instead of using check, you just use OPA score. And I'm just echoing the results out here, which we can see here. So Terraform plan, this is your standard plan. It gets state log, does all that stuff. And Terraform validate, it tells us that validation result is false because in this particular plan, we are deleting, we're actually replacing the Kubernetes cluster node pool. Just because for this demo, we wanted to delete something. So deleting a Kubernetes cluster node pool is a big problematic task. And that's exactly why we had classified it as, I think this might be an old one. There you go. As an important resource, which gives you a deletion score of 99, which will immediately fail your acceptable score test. So having that deleted, it says not fail, you've got a score of 99 when your maximum acceptable score was 2. So auto apply and manual apply, those are the steps that it's a bit out of scope in this particular talk, but This itself, what we're doing in the pipeline is that we're setting a set output of validation pass. So that way you can use this down. If validation pass equals true, you run auto apply. If validation pass equals false, you run a manual apply step. And ideally here you would add an extra step of, requires user manual approval, which in this case we had not done yet. But yeah, you in GitHub you have the option to allow a user to manually review it before it actually proceeds. So once the review task is completed, you can just run Terraform apply. In this case, we just commented that out because this is just a demo and we don't actually want to delete our Kubernetes cluster. And just for safety, we're just removing the Terraform plan. But this is the pipeline from start to end. And generally, what you would need to update if you do clone this repo, all you do is change the path to your Terraform files, update your variable files, and replace your rego if you don't want to use our regular one. Everything else would work as is. Well, and then you have your apply steps, I guess. Any comments thus far?
No questions yet. Yeah, if anyone has any questions, please reach out to us or comment on the chat.
So yeah, this is how you see the entire pipeline working end to end with the auto and manual approval steps. And once that's done, it just stops the container. And the main reason why we did use a container was it just simplifies a lot of the steps. You just do your regular Terraform steps of init, plan, apply. There's no additional steps that you need, like download OPA, download TFSEC. You don't even need to download Terraform because it's already baked into the container, which we can show you here in our Docker file. So all it's doing here is it's curling, getting the release of Terraform 1011. Now, those of you that are actively working on Terraform, you'll know that this isn't the very latest version. The reason for that is that TFSEC has Terraform had a breaking change when they went to 1.1. I think the current version is 1.14, thereabouts. When it went to 1.1, it had a breaking change that made TFSEC unable to do the scan. So that's the reason why at the moment we're baking it to 1.0 minor versions. But once TFSEC is fully up and running, we would just be incrementing this to using the latest, greatest Terraform versions, just get all the bug fixes out of the way. So as I mentioned earlier, we are getting TFSEC in here. OPA itself is...
OPA is imported through the Golang.
OPA is in the Golang, so yeah, we don't need to actually download that. So TFSEC is done. OPA is actually part of that up here where we're building it. And Terraform is here. So the three dependencies, OPA, TFSEC, and Terraform CLI itself, they're all taken care of here. And then you can just use it. The command to actually use it is just Terraform plan validator, as you see here, and as you've seen in how we're calling here, just Terraform plan validator. And the commands, which we showed earlier in the talk, you've got check, you've got OPA score, and the last one I can't remember now. Check, OPA score, and TFSEC, yeah, and send report. So use these as you see fit. You can just, they've got the parameters here on how to use it. So you can just pop that into your pipeline. You could always send a report of, sorry, where was it? So check, OPA score, send report. You can add that as an extra step in there to say that, we've done the TFSEC review of this particular repo and we have found this many vulnerabilities. You could always bake it into part of here. And that way it'll just send a webhook to your Slack and say, please review. You've got vulnerabilities that should be addressed. Otherwise, if you don't send that anywhere, a dev may just go in and go through here and say, hey, it's all green. There's no errors, and not actually look at the report because we had done a soft fail in this step. So you could, if you did do the soft fail like we have, it's recommended that you do send the Slack webhook so someone is actually aware of the vulnerabilities that are in place. Otherwise, you can just take that out and let it actually break the pipeline until someone really does address the issues. And I think that's what we have at the moment on these guardrails. Do we have anything else that we would like to add on? You're on mute, Brad.
Just the roadmap, I think. So we're trying to make it as simple for people as possible, and without reinventing the wheel. But I guess the next thing we want to do is to have an actual GitHub Action plugin where we sort of handle all that other logic of Terraform, and you can add your extra parameters if you have them, and just really making it really easy for the user, so you don't really need to worry about that stuff. So yeah, things on the roadmap. We have integration with Azure DevOps as well. That's really cool. We've got it working with Bitbucket pipelines, and yeah, there's a lot of. I'll share my screen then, and I'll just show what the Slack output looks like as well. Also on the roadmap is Jira integration. So we want to, when we do get these error messages, we want to actually create a Jira ticket. If you want, obviously all these are optional, but it will create a Jira ticket with all of the steps. So it's essentially automating someone's job. So it says, go here, change this, and that's going to keep us honest with things that are changing. There's always security vulnerabilities coming up all the time. So what I'll do is I'll just show you what it looks like in Slack as well. So you can see here in the Golang code, we're getting the TFSEC JSON output, and then we're massaging the data to work as how Slack wants it, and then we're sending it as well. So all you need for that is you need to pass in the Slack webhook parameter, and that's all you need. And then you'll see here that if you have critical, it's red. That's warning. So this is the problem, and this is how to solve it. So we'll probably have some hyperlinks as well to click to the documentation there, but that's just, it's all about keeping people honest as well. So if you had that in like a security alerts channel, in companies, a lot of security is sort of swept under the mat. So we've found, haven't we, Ben? We've found that this really helps us keep ourselves honest, and every small vulnerability can actually be a big one. So it's been really good to see it pop up and say, okay, let's actually do something about it. And this has been great to have that, the accountability for it as well. And everything's audited, like every pipeline you can see that has these logs, and you can even see it to the commit, that's done where it caused the incident. So yeah, I just wanted to show you the Slack stuff. Do we want to show the Azure DevOps, like the pretty graph, Ben, or another time?
Let me see. So let me just get that up on screen so we can get that ready.
We'd probably like to do, we have TFSEC has really cool PR commenters as well. So when you raise a PR, the automation will kick off and then comment to that PR saying, yes, this is good, or not, it's not. So that's something on the roadmap we'd like to do as well. So you can see here, this is what we've done in Azure DevOps, and this code will be available in the repo as well.
All this does is, because we are doing multiple environments at once, that way these four can kick off in parallel, and all of them go through the same OPA policy that you had seen. If it passes the score and TFSEC requirements, it will then send out one of these notifications. Plan has passed validation step. It's safe for the pipeline to proceed automatically, and it'll just go through there. Now, what we have done is for prod, we just don't even give that option. Prod will always require a manual review. So in any case, if the UAT, for example, if we did the exact same thing of deleting a cluster or deleting something that's not supposed to get deleted, it'll just hop over to this manual approval step. And what will happen is that it'll just hover here saying waiting for manual approval. Someone has to go in there and click on the approve step. Ideally, the best procedure is before you actually approve it, you check on the plan and see, okay, what exactly is being updated. Well, in this case, there's no change, so there's no issue at all. It can just proceed, and that's it. That will just then manual validation pass. In this case, I had reviewed the plan and said, yep, it's all good, proceed, and it'll just do its thing. Now, don't be scared by the 35 minutes here. That's 35 minutes of the server actually waiting for someone to review it. It's not that it actually took 35 minutes to deploy it. It's like 50 seconds. So that's how the Azure side works. And we had not baked this particular, left-right branch into the GitHub action yet. I mean, it already does work. It either goes auto or manual, but we had not put in place the manual approval guardrails in here yet. The ways that this can be done is you can set an environment for, in this Terraform manual apply, I think it's one of those parameters where environment -- prod, something along those lines, and you can have one of those settings in place that says if the environment is prod or review, then it will require user approval. But it was just a bit out of scope for what we were going to be doing today, so that's why we had not put that in place. But that aside, you can kind of visualize how this works with plan, validate, auto apply, manual approval. So one other thing that we had actually considered doing for this is to make it work similarly to how with this kind of graph. We wanted to do it as stages where there's just your plan validate stage and your auto apply manual apply stages. Now, one of the issues that we had with that is it requires you to publish an artifact from one stage to another, and that artifact would be freely downloadable. And the problem with that is Terraform plans actually store sensitive information in plain text. So that's not something you should ever put in the public realm, especially on a public GitHub like this one. So that was one of the issues that we had in place. That's why we didn't really complete this piece. Whereas what we had done in the Azure side of things is that once we've done the plan, we upload it into a storage account. That's for our auditing purposes as well. In a way, when something has gone through this auto approval stage, if we ever needed to check back exactly what was done, we have access to that Terraform plan to be able to see it because it's stored in a storage account. And at this step, it just does an upload, this does a download. So when you're in the second column here, it doesn't have access to anything that was done in the first column. It all just gets wiped clean, like your typical pipeline type scenario. So that is a way that you can similarly do in GitHub. You can upload it somewhere if you want the audits, or I'm not sure, does HashiCorp Vault work for this type of scenarios? It may or may not be able to let you do this kind of uploads. I do know that in Azure Key Vault, it didn't like it because some of these plans, especially when you have too many files, there's like a character limit for Azure's Key Vault itself. So when I tried putting it to Key Vault, it was unhappy, and that's why we went with the storage account rather than Key Vault, which would encrypt everything. But so when we did upload it to the storage account, we just made sure that there's no public access. It's all locked down, and that way, even though it's in plain text, we try to put as much security as we can to this storage account. So if I personally don't know about the HashiCorp Vault side, ideally it should be able to do it. I've not tested it, so give that a shot.
Yeah, we can put that on the roadmap and try that this week or next week.
So that person will be able to just supply your credentials to your pipeline, and that way it stores all your plans and in a safe, secure way, and you'll just be able to do the multi-step stage deployment type thing.
Yeah, so it's debatable whether you need to store it, because you could always reference the commit SHA and then make the plan from that, I guess. So
you could always just redo the plan in here. Yeah, that would also work.
Yeah, because the environment variables will always be in that deployment folder as well.
That's a good idea. Actually, we can always just in the apply step just redo the plan and apply it. Yeah,
because it's sort of like you have all your secrets in Key Vault, but then when you go into use your Terraform plan, it puts them all there, so it's like defeating the purpose in a way.
Yep.
Yeah, you might as well store your secrets in storage account if you're going to do that.
Yeah, it's quite a lie when they say, I think there's, let me see if there's it doesn't actually show up, but sometimes it just, does, the bracket sensitive, but when it's inside your JSON file, it's plain text for anyone to see. So it's a bit cute.
Yeah, because you wouldn't want to make a security tool that actually has vulnerabilities as well, right? Because it happens quite a lot. I've seen that happen quite a lot as well.
Yeah, so this is what we have built. We're really proud of it. We hope you guys will also use it, and let us know if you've got any feedback, what areas could be improved. We're always happy to accept pull requests and anything else that you think this is having any shortfalls in any way. So the two repos that we had just shown you were the Terraform plan validator and the AKS. That's more of just like a demo thing that you can go through the source and see what we had done. This AKS repo is actually for a previous talk that we had done, which is this, creating an AKS cluster with Terraform. So if you actually do want to find out how to create an AKS cluster with Terraform, the links are right in here. So let's just pop that up on the screen again. Terraform plan validator and AKS. It's just the last bit at the end that you need to swap out. So do we have anything to add?
Yeah, no questions. But no, I think that was a great talk. And like Ben said, please reach out if you have any issues or you want us to help. We're more than happy to help set it up in your environment as well. And just raise an issue if you want some feature requests on it as well. All right. Thanks, everybody.
Thank you, everyone.
See you at the next one. Cheers. Bye.